and that will be Ruben, who will be speaking about stream processing with riko.
Riko. No problem. Okay, so first off, I'll just introduce myself. Currently, I'm the Managing Director of Riko Development. It's a software development firm focused on back-end systems and data analysis. I've been programming in Python since about 2011, so around 6 years so far. I'm the author of several popular packages, one of which I'll mention in this talk today, which is Riko. Another one is called Meza, which is a data analysis library, and I'll be giving a workshop on that tomorrow. Third one is called PyGoGo. It's a logging library, and it's used under the hood in the two previous libraries. And also, just to give you an idea of some of my preferences, prefer Flask over the Django, Twisted over Tornado, and functions over classes. Okay, so streams. Essentially, a stream is, you can think of it as a sequence of data or a sequence of pieces of information. So if you look on the left-hand side, just imagine those two circles as being, think of it maybe as an integer. Each arrow represents a transformation or a function that you apply to that piece of information. And as you move left to right, you apply different functions to the pieces of data until you get something completely different at the end. And just to give you a visualization, so at the top, you can think of it as a stream of 3 integers, and then the bottom are 3 different transformations. So the first step is just multiplying by 2. The second one is filtering for anything greater than 2. And then the last step is an aggregation, so it's just creating a sum. So as you move along, you get the first item, which is 1, you multiply it by 2, and then you get 2. You go to the next step, the filter looks to see if it's greater than 2, it's not, so it goes away, and then you multiply the next item by 2 and you get 4. You go down again, and the filter looks to see if it's greater than 0 or greater than 2. It is, so it stays, and then the next item gets multiplied by 2, and then you get 6. You go again, so you're summing for the first time, and so it just stays 4. The 6 is greater than 2, so it stays. You go to the next step, so now you add 6 to the result, and you get 10, and then your final output is 10. So that's just to give you a really basic example of a stream process. If you're doing complex stream processing, then you can work with anything. It doesn't have to necessarily be integers. And we'll get to that in a little bit later. So next I'm going to show you how you actually construct streams by using Python. So first, this is just looking at a stream. So in Python, a stream is anything that is iterable. And so a stream by itself is iterable. So if you just look at the first value, you get the letter A. Now we're going to actually take a phrase. We're going to split it by spaces and then get the first item, which is here, hello. Next, we're going to just create a list of numbers 1 through 10, and then getting the first item here, we see it's 1. Here, we're just going to use list comprehension, and get the first item, we just get a dictionary with the key of X and the value of 0. And this third form is what we're actually going to be using going forward. So each stream is going to be represented by iterable dictionaries. And this is similar, so instead of using a list comprehension, we're doing a generator comprehension. Who here is familiar with generator comprehensions? Just like an idea. Okay, cool. So a little over half. So for those of you who aren't familiar, this essentially helps you save memory. So instead of realizing the entire list at once, you just get back a generator object. And what you have to do is call next on the generator object. And when you call next, then it gives you the next value that's in the stream. And this is really useful when you're working with larger data sets that don't necessarily fit into memory. Okay, so now we know a little bit about streams. I'm going to show you a few things you can do to process those streams. So now back to the list comprehension. Here we're just going to use a function ORD. And all that does is just takes a string and it converts it into an integer. And so when we do that, we have the word abracadabra, and then we get back a list of integers. Again, here's something simple. We're just multiplying everything times 2. So you have a list of 1 through 10, and then you get back 2 through 20. This is similar to the filter step that you saw in the visual. So this is just looking for any integer greater than 5, and then we get back the list 6 through 20. And now this is going back to the generator comprehension that I showed you earlier. So now we're representing the string as a lazy list, like a lazy list of dictionaries. And then in that second step, what we're doing is looking at the number key, and we're just summing all the numbers within that list. And then you can see here we get back 10. So it's adding 0 plus 1 plus 2. Sorry, we get back 6. So 0 plus 1 plus 2 plus 3 is what gets you 6. So okay, you know string processing, what string processing is, but so what? Why does it matter? So what I'm going to do now is show you some examples from several websites which use string processing under the hood, and which you may not know about. So who here has heard of Feedly or has used Feedly before? Okay. So what Feedly is a website that allows you to take articles, or it could be a blog post, it could be articles from CNN, BBC. Most of these websites expose what's called an RSS feed. Feedly is a RSS feed reader, so it's a website where you give it links to various RSS feeds, and it aggregates all the articles in those feeds and then presents it to you in a nice free format like this. And so essentially, under the hood, what they're doing is they're using stream processing to aggregate the stream of articles from each feed, extract the image, extract the content, the author, the title, and then present everything in a pleasant format. This next example is Kayak. So I actually used Kayak when I got my ticket to come here. So Kayak is an aggregator, and so what it does is it looks at prices for flights, hotels, car rentals, and it gathers all of those prices. And when you give it queries, it filters through its database to find either the flights or cars or whatever you're looking for that meet your requirements. And since it's taking data from various sources, they aren't necessarily in the same format. And so along the way, they're using stream processing to help normalize their data so they can get everything and present it to you in the way that you expect. And then this last example is what I call a mashup. So I was looking for a website that did some kind of mashup with Twitter, and I found this one called Portraiture. So what you do is you give it your username. So I'm Rubano on Twitter. It looks at the tweets that you tweeted over a period of time. It then takes those tweets, extracts some keywords, and then uses the Flickr API to find interesting pictures that correspond to the topics you tweeted about. So it says I tweet about Nairobi workshop, Kenya, and so you can see these are the images that it thinks correlate to those topics that I tweeted about. Okay, so next we're going to look at a few different frameworks. So if you've done any stream processing, you may have heard of some of these. So these are Flink, Hugin, Hadoop, Storm, and Spark. And people use these frameworks to do different types of stream processing. I'm going to take a look at two of the frameworks before then telling you a little bit about riko. So first, this is just giving you an example of the data that we're going to be using with two of the frameworks. So it's just a simple text file. I just went to Google and searched for lorem ipsum, and the first link that came up, I just copied the text. So if you have this text file, saved on your file system, and you have a goal to figure out what words are used in the file and how often. So first, I'm just going to show an example using Hadoop. Okay, so I'm going to go through this quickly, not going into too much detail, but there's a few important things to look at. So one is the Mr. Job that you're importing. So every class that you create just has a subclass, Mr. Job. And then within each class, you have to at least define a mapper and a reducer, and the combiner is used just to help optimize things, because what Hadoop does is it parallelizes your task across different machines, and the combiner is basically like a mini reducer that operates on the parallelized machines before sending it to the final reducing step. And then what you return within your method steps is just a Mr. step. And in this example, we only have one step, but you can have MapReduce that requires several steps. And since it's in a list, you just basically have a comma, and you can list as many Mr. steps as you want. And so this is further down in the file. So the mapper, reducer, and combiner that I mentioned before, you just define them as methods. And so here you can see they're just using regex to look at each line, find each word, convert it to lowercase, and then in this case the combiner and the reducer are the same thing. So what it's doing is taking each time the mapper yields a result, it gives 1. And so in the reducer, you're summing all the ones according to the word. And so what you're able to do is you're able to see how many times each word was used. One thing I didn't like about Hadoop is you actually can't run it interactively within Python. That thing at the bottom is what happens when you run it in the command line. And so you actually have to take this file, run it in the command line, and then give an option of the file, of the input file. And so that's a little bit annoying. And you can see, kind of verbose. So this next example I'm going to show you is Spark. And here you can already see it's a lot less code. You're able to do pretty much the exact same thing. The nice thing about this is that you can do everything within Python, so you can do it interactively within the IPython shell. And you can see here, so I'm defining the file. So it's reading from HDFS, so you just give it the path to the file, and it's doing the same thing. It's looking at each line, splitting it by a space to find the words. For each word, it's converting it to lowercase and then yield to 1. And then for each key, sum up how many times 1 was there. And one of the things to kind of notice is the first step is a flat map. And that's basically because you wind up having a nested list. And so when you do a flat map, it unnests the list for you. But it does the same thing that the Hadoop version did in fewer lines of code. And so when you call collect, what you wind up getting back is a list. And then in this case, you call the first element of the list, and you can see, actually, slight typo, so I don't think the list is going to be in a dictionary, but I don't run Spark on my computer, so I actually don't know what form it's going to be. I think it just might be a tuple. But it's the same idea. You get back the first word, and then how many times it was there. Okay, so next I'm going to introduce riko. So what riko is, it's a stream processing library, and it's in pure Python. And essentially, I wanted to have an API that was similar to the way Spark allows you to do things. The way it actually came about is there was a project that I was working on that required using Yahoo pipes. How many people have heard of Yahoo pipes? Okay, so Yahoo pipes was discontinued by Yahoo. And actually, at the time, I kind of saw the writing on the wall because the last entry in the Yahoo Pipes blog post was maybe 4 or 5 years old. So I was looking for a way to do what Yahoo Pipes did. And what it did, for those who don't know, is allowed you to fetch RSS feeds from the web and then do transformations on those feeds and then output a new feed. So I was looking for a Python library that did the same thing. And I found one called Pipes2Py. I wound up kind of optimizing that library and rewriting a lot of it. And then it got to the point where my edits diverged so much that I just created a new library. And so this is essentially, if you're familiar with Yahoo Pipes, some of this will make a lot more sense. So as I said before, you're able to fetch feeds from across the web. And in this case, you can take CSV, RSS, JSON, and HTML. And the output is a Python structure. And in this case, it's an iterable dictionary, similar to what you see there. Okay, so first, just to get into the basic usage. So it's available via pip, so this pip install riko. And now I'm going to do the same example with parsing that file, this time using riko. So what you do is you import what's called sync pipe, and sync pipe is what allows you to do the method chain that you saw in the Spark example. There's going to be a few parameters that you set. So first is URL to the file. Configuration, when we do the splitting, we just want to split by spaces. And then the rule is going to be for the transformation that we're doing. So you can see here, when you pass, what you pass the sync pipe is a string of the type of data that it is. So since it's a text file, we're just using fetch text. The configuration is going to be the URL to the file. We're going to do string tokenizer, which is what allows us to tokenize each line by the space. And then you can see where that emit equals true. That's similar to how PySpark did the flat map. So when we do emit equals true, it just takes what would be a nested list and flattens it into to a plain list. We transform it by lowercase, and then we're going to count by the string transform. And that just is because when you do the transformation step, it outputs the result into a new key called string transform. So in this case, what you get back is a generator. And so when you call next on it, then you get the dictionary. So similar, you get the same result whether you do Spark or Spark. You call next again, and then you get the next word. Okay, so now we're gonna do another example using data that we can actually get from the web. So in this case, we're gonna use some data from Code for South Africa. Is anybody here representing Code for South Africa? Just curious? No? Okay, so Code for South Africa, they have a site, Open Data, which is data about South Africa. So once you go to the website, there's an option there taking you to the data. So you click that and you get a list of the catalog. And so what I did is I just sorted it by most access. And then the first one there was statistics, crime statistics from the police. And so we're going to be using data similar to this. So I'm not actually going to use the whole data set. It's a filtered data set. And just because we're making web requests just to keep the latency down. And so here, it gives you a nice way to export the data. So there's actually an API endpoint, which outputs JSON. And so for these examples, we're going to be using this URL. So what you'll see is just you're going to pass the URL, and this is going to be a path to a JSON file. Okay, so in this case, we're not going to be doing any chaining. And so we're just going to input the fetch data module directly. So as before, you have a URL that you pass into the configuration. And then when you call the pipe function, you get back a string. Oh, sorry, you get back a string. So when you call next on the string, then this is the first data item that's there. So in this data set, you can see that essentially what they have is they classify all the crime that happened within South Africa, and then they attribute to a police station the number of incidents, year, and the province. And then if you call next again, then you just get the next item. Okay, so now we're going to show a couple of different things we can do. First, I'll just show you how you can filter and truncate. And here, again, since we're going to be doing method chaining, we're importing this sync pipe class. So first, what you want to do is you have your filter configuration. And here, we just want to filter where the province is GP. And then we're going to sort it, and we want to sort it by the number of incidents. And so here it is. So as before, you have sync pipe. It's fetch data, which is a module that handles JSON. The configuration with the URL. There's the dot filter, so you pass the filter configuration, sorting configuration, and then for truncating, you just want the top 5. And so what you get back is the stream, and you can see here. So this is off death not mentioned elsewhere. Over 3,000 incidents, and then you call next again, and you can see the number of incidents is slightly lower. so, you can assume it works the way that I said it did. Okay, so the next example, I'm just going to do a simple join. And you can think of this as a join that you would have if this was a SQL table. So here we're going to be just importing fetch data in the join modules. The data that we're going to be joining here is URL2. And it's also crime data, but it's another crime data set. And I'll just kind of show you what this data looks like since you haven't seen it yet. So what this has, it has each station, each police station, and then the total of crime incidents for the 2014-2015 year. And so now what we want to do, since we're joining, we have a join configuration. And so in the first data set, the key is police station, and the second data set, the key is station. So here we're just saying that we want to take those two data sets, and anytime those two keys match, then merge that data together. So then the result that you get, you can see here, this was the original data that was in the first stream, and then that's the additional data from the second stream that's been merged together into one dictionary. And this is just showing you the next item for the same thing. And so what I showed you just so far was one basic usage of it. So riko actually has a few different APIs. So that was the synchronous API. It also has an asynchronous API and a parallel API. And so I'll give you an example of using the async API. So under the hood, it uses twisted. But as you'll notice, the imports aren't going to be exactly the same because twisted was before PEP8, and they use camel face. So I actually have a small wrapper that uses the more conventional PEP8 lowercase. And so you just pip install riko async. And then new things you can see at the top are the coroutine, React, and then there's going to be the async collection. So in this case, what we're going to do is we're going to give it two URLs, and we want to collect data from both streams at the same time. And so you just pass a collection, your sources, and a list. And there's a coroutine decorator. And so when you actually run this in the reactor, then you get the result of the next item in the stream. And so this was just like the very first example that I showed you. It's just a dictionary with all the police statistics. Next, I'll show you how you do something similar using the parallel API. So you can use multiple threads and also use multiple processes. And so this one, I'll just show you how you do it with multiple threads. And so in this case, instead of an async collection, we just have a sync collection. And it's similar as before, so the same sources, just a list of URLs. You pass parallel equals true, and then you can see the first item of the stream is what we had before, and then here this is looking at the last item in the stream. And so this is the second data set. And so you can essentially pass it a list of as many URLs as you want, and you're able to fetch data from all of those in parallel. And then there's processes. So when you want to use processes instead of threads, you just pass the argument threads equals false. And then when you do that, you are using multiple processes instead of threads. So if you have some fetching that involves using the CPU instead of input-output, then you would use this method. Okay, so now I just kind of want to show you the differences between riko and some of the other stream processing libraries that you may have heard of. So first, just looking at installation. If you ever have used Spark or Storm or any of those other ones, the installation method is quite complex. You usually have to install Java. You sometimes have to run a cluster. You can see in the Hadoop case, you can't even run it within Python. You need to use the command line. Qgen is a Ruby library, and it's similar to if this then that, but it does some stream processing. It's a little easier to install, but it actually requires a database. And so compared to Riko, which is pure Python, and it's the easiest of all of them. The main difference between Riko is that Riko is pool-based. So as I was showing you before, on those examples, you call next on the stream. And so what that means is that you have to ask for the next item of the stream, whereas with Spark and Fusion, they're push-based. And so what that means is with those libraries, you're actually able to react to changes in the data as it happens. So for example, with Fusion, you can connect it to Twitter, and you can say if the number of times a certain item is mentioned surpasses a threshold, then send me an email. Whereas with Riko, it doesn't have a push-based API, and so you're not really able to react to events as they happen. Another difference is the ingesters with Spark and the others. They're usually just focused on text and JSON. Once you go to Fusion, it adds RSS, and then when you're looking at Riko, it has even more ingesters. So it's able to parse HTML and XML as well. And then looking at being parallel, all of them you're able to run in parallel mode. But as far as async, from what I've looked at least reading the websites and documentation, neither Spark or Storm or Fusion have an async API. And then finally, distributed. Riko is meant to run on a single machine without a cluster, whereas Spark, Storm, etc. are designed for being distributed and running on multiple machines. Okay, so that's it. And I guess we'll open the floor for questions now.
Okay, any questions?
When you run Riko in a continuous stream mode, so continuously putting from, say, an RSS feed and processing it every time, or is it just a one-stop solution?
Could you repeat? I'll repeat it for you. So he was asking if you can use Riko to run it continuously. So if you have a stream, just run it again and again. And the answer is yes. And so actually there is an application that I built on top of Riko which does that exact thing. So I just had a twisted server, and I just ran it on a loop. And so it just had I had the URL set, and it ran the stream every X number of minutes, and if there were new items in the stream, then it would just persist those new items in memory. Does that answer your question?
Any further questions?
So I noticed you use quite a lot of text for configuration of your calls in Riko. Is there a more fluent interface available? Is that or still something work in development or under consideration?
Yeah, so it's something I'll take under consideration. I can kind of tell you how that came about. So this originates from the library, which was meant to duplicate the Yahoo Pipes way of working. And with Yahoo Pipes, essentially it stores all the configuration in JSON. And so Riko was actually meant to work in a similar way. And in comparison to Spark, I don't know if you know this, but in the mappers and the reducers, you pass pure Python. In Riko, you pass text. And so I look at it as a feature, not a bug, in the sense that you can have a service that accepts JSON configuration, and you can pass Riko just essentially pure text. So that way you don't have to worry about passing Python structures back and forth.
One of the differences between Spark and everybody hear me now?
I'll repeat it. Just
Okay. One of the differences between Spark and Riko was that they push and Riko's pull. and there are certain use cases where you want to get events that are full. So that's a use case that, if I'm understanding correct, Riko doesn't quite hit. So are you planning to extend Riko to full that use case?
Yeah, so the question was going back to the chart I had showed before, which was just a push versus pull. So since Riko is pull-based, you can't currently respond to events as they happen. And yes, I would like to have that feature. For me, the question is the best way to do it. And I haven't really seen a best practice for using the stream, paradigm to implement a push version. And so I've looked. I know Dave usually gave a talk about coroutines, and there's a way that you could do with coroutines, but in the method he showed, it had like its own version of callback hell. So another thing is being pushed. You can have a stream be sent to multiple sources, whereas in pool-based, you can only have one consumer. And so that's also another disadvantage. But I guess to answer your question, when I find like the mechanical way to implement push in Python, then I would like to go down that road.
We have time for one more question.
Now, what about performance?
So the question is about performance. The answer is I don't know. I don't run Spark or Storm or even on my computer. I don't wish to deal with Java. But if there is anyone who has used those and has a nice benchmark that that they could send me that I could use to measure it, then I'd be happy to take a look. Some of the things that I've tried to do is make everything lazy by default, just so that it doesn't use up much memory. But as far as speed, I have no idea.
Okay, let's thank our speaker.